All right, folks, just in the nick of time, we're here to dive into the world of TCP. My name is Dan Young, and we've got a really interesting perspective on something that I think most of you have probably already seen, okay? Most of you have probably already seen a discussion of TCP, and it's pretty commonplace, but we're going to take a different perspective. We normally are going to just kind of see an introductory level discussion. And we still only have an hour. But in this hour, you're hopefully going to see some things and get a little bit better understanding of the technologies. And we're going to frame TCP and our discussion specifically around a few different attacks. So when I was thinking about this discussion, what I wanted to do is I wanted to give you something that you've probably not gotten an opportunity to understand a little bit better, right? So we're going to see the headers. We're going to do kind of the level set just to make sure. So if you're really fresh with TCP, that's okay, all right? If you're really fresh with TCP, that is okay. But if you are needing, for instance, some perspective on what some of the fields do deeper than what we normally get into, this is going to be tremendously powerful, okay? So we're going to look at some specific attacks. And we're going to do that not to frame this as a security discussion, okay? We're going to do this to teach you beyond what is normally taught, okay? And so there's some persistent issues with TCP because inherently it does not secure itself. It's got some really basic security features, but they are as basic as they come, okay? So that's going to get into things like session hijacking, okay? Session hijacking is something that was used even by the NNSA or NSA. You've heard the term or the name Edward Snowden. Edward Snowden exposed some of these attacks. And we're not going to go crazy deep in the attacks, but we are going to talk about the component of TCP that enables them. And these are two different types of attacks that leverage session hijacking. We're going to do a port scan. We're going to do some port scans so we understand a little bit more. We're going to look at different elements of TCP just in a number of different ways. So we'll start by reminding us of TCP. Now, when we think about TCP, we have to understand that this is a stack. Okay, so we're not going to talk about IP today. Okay, so we're not going to talk about IP addresses. We have other discussions that get into that. We're going to leave that and not worry about that one bit, okay? What we are going to do is we're going to talk about this portion of TCP, and we're going to take moments to go into some of the different elements a little bit different, okay? So the top two, and let's use this as an opportunity to level set you on the fields of TCP, and we're going to dive deeper, okay? So I want to do this kind of quick, not because I don't care about it, but because we're going to get deeper later on. So the first kind of area that really impacts us in the world of IT is understanding ports, okay? Now, port is a term that is used in a lot of different ways with respect to how networking works, right? We might think of a port as an interface, right? But these are virtual numeric values. These virtual numeric values are there to keep track of the individual conversation and the session, if you will, that is going to be formed, maintained, and torn down during a conversation between two different IP endpoints. TCP manages that. So we're going to see a list of destination ports that I would talk to. So if you have some destination ports that you happen to know, some well-known TCP ports, go ahead and chat them into the group. just to kind of remind us all, yes, this is one of those things that as an IT professional, you typically pick up maybe 5 or 3, 5, 10 different ports that you remember. Okay. And this is not a measure. Okay. So I don't want you to think, oh, I don't know that port, so I shouldn't be here. Okay, I've been there, right? You could throw out a port number that I don't know, and this is just not a measure of anything, except sometimes on the certification exam. But if I'm talking to, great, Jim chatted in 21, that's FTP. Okay, so if I'm talking to an FTP server, I'm going to be talking to 21. Anthony, port 80, which we try to not use anymore. And that's super important that we do not allow even redirections from 80 to 443. So destination port 80, destination port 23 for Telnet. I see some DNS. We're going to be talking mostly about TCP today. And a lot of the DNS communication is UDP based. Okay. All right, cool. Yeah, I got some chats in there. 3389. All right, great. So we'll see how this works. That relationship is going to be important to us. More on that later. Then we're going to have sequence numbers and acknowledgement numbers. Now, when we teach this in a typical class, we're going to teach it in terms of this affords us the ability to have reliable communication. And so the reliability of TCP comes by way of sending communication out that is sequenced and awaiting an acknowledgement number. And the acknowledgement number indicates whether the traffic was received or not. But that's actually not what's really important, and that's not what's going to make or break your understanding of TCP. So that's just kind of a fact. We normally don't care about that too much, okay? So then we have header length, nothing exciting here. Reserved, nothing exciting. Flags. Wait a minute. This is a big deal. Okay, so we're going to go deeper into flags than you probably have ever seen before. Doesn't mean we're going to cover everything to the most gory detail, but flags absolutely matter, okay? And so at a high level, I want you to understand that when we talk about flags, I want you to think that this is an 8-bit field. Okay, so it's an 8-bit field, and it allows us to identify different states of the conversation. It allows us to communicate what we want to do with the conversation, whether we want to tear it down. And so there's a lot of individual flags that are deeply important to the operation of TCP, and we're going to get in the weeds on that one. Okay, we're absolutely going to get in the weeds on that one. Going further into the discussion, window size. So window size is super crazy complicated, believe it or not. And what we should understand at a high level is window size controls and conveys how much I can send without waiting for an acknowledgement. And so I want you to think for a moment, hey, if you have cell phone conversation. We do this as human beings. We change our window size in the conversations that we have. Let's say, like when I drive from the Phoenix metro area to Flagstaff, that drive takes me through areas over this 140-mile drive where I have terrible cell phone reception. If I'm talking, I am going to change my speaking cadence so that I'm saying 1 or 2 words, not a full sentences, not like my normal flowery conversation that has all sorts of unnecessary words in it, okay? And so we do this. We shrink our window size, and that allows us to get communication even over a slow, unreliable connection. We greatly increase our window size to allow us to communicate more. But there's a problem here that we normally don't get into. And that problem is, as I go back a slide, the problem is window size is a 16-bit field, which means it allows us to send 64 kilobits or kilobytes. It's an indication of the number of bytes, 65,536 bytes but communication is a lot faster these days. So we're going to get into something called window scaling. So that window size is not to be taken on faith. Not anymore. Not since Windows Vista. Okay? So then a few other fields, TCP checksum, urgent pointer. Don't worry about that too much. Okay. So now let's go out to an environment where we're going to spend a little bit of time working in these systems. Okay, so I'm connected up to CyberRange, our CyberRange specifically, and we're going to generate some traffic. It's going to be pretty heavily TCP based traffic, and we're actually going to capture the traffic as it happens. So I want to say something, and you could mistake why I'm showing Wireshark. Okay, so you could see, yeah, I've got Wireshark going, and you could be intimidated by this. But where the rubber meets the road, really, when it comes to traffic and understanding how protocols work, is actually to see it. Okay. One of my networking buddies and I were watching a really cool security video, and it was like, hey, if it isn't in a PCAP, it didn't happen. And PCAP is the general file extension that we have when we're talking about network traffic and capturing. Okay, so I'm just gonna stop this capture because we're seeing just a ton of stuff. And let's first see the fields that we're going to get into. So I'm going to make this a little bit bigger. Okay. We're going to go into packet right now. And we're going to crack open those same fields. Okay. Yeah, and I'm not going to save any of these captures today. Okay, so this is an ongoing capture that we have. Okay, so I just showed you the theory, kind of just like typical slideware type stuff. It was pretty, but it was still just the theory. Okay, so I want you to see how I'm going to follow this conversation. Okay, so we're going to see a lot of good stuff here. Okay, I'm going to close that. And we're going to look at a conversation in the world of TCP. And so much can be gleaned from this information that we're looking at. So much, okay? So I'm going to take a look at the very first, what we're going to call segment. And you might hear the term segment and go, why is Dan not using the term packet, okay? So there's just a little bit of nuance to the terminology that people use when they're describing TCP versus IP versus like an Ethernet frame. Ethernet is layer 2, so we call it frames. Packets are layer 3, and segments are, layer 4. And TCP is layer 4. So I'm doing that purposefully. So I don't want you to think that I'm somehow trying to use a term that doesn't really matter, okay? It does matter, and I'm just going to try to be super accurate because I think this is that opportunity. Okay, so the first thing that I want to just expose, and we're going to talk about this a little bit more detailed, is flags. Okay, so when we are talking about the nature of TCP, TCP is highly session oriented. And it is going to maintain those sessions. And these flags have a lot to do with it. You can see that there's a bunch of flags. There used to be just 8, but now there used to be 8 bits. Now there's a few more. We're going to talk about urgent, acknowledge, push, reset, SYN, and FIN. Okay. So the ones that really matter. The explicit congestion notification is a QoS mechanism. We're not going to care about that too much, okay? Not going to care about that too much, okay? But I wanted to share with you the relationship of ports, okay? So ports going back, yeah, I got to scroll up a little bit. Okay. When we say port, when I have an IP packet and I'm communicating with a destination endpoint, if it's TCP based, I'm going to be knocking on the door of a server's service. Okay. So let's say you're going out to a website. We all do it, right? We go to websites. And when you're going to a website, you're going to its IP address, but you're also going to its well-known port for the web service. And nowadays, that well-known port is actually 443. Okay, you might think of it as port 80, but it's something we can't really use anymore because of it is fundamentally something that is inescapable in terms of a security problem. Okay, and we'll talk a little bit about that today because session hijacking enables that. Okay, so the destination port is an indicator of the service that runs on top, specifically the application layer. And this one that I've demonstrated is port 22. So port 22 is, and I bet it was one of the ones that was chatted in. Okay, let me just see. Did anybody? Yeah, John E said port 22, right? So that's secure shell. Okay, so secure shell is a more secure version of Telnet and all that good stuff. Okay. What I want you to see, though, is the back and forth relationship of the port as it comes from the client. Okay. So this is something that we sometimes see as a little bit of mystifying. There's a different port that comes as the source. Let's talk about that. So when we are a client, and we're going to communicate with a service, I am going to randomize my source port. I'm going to randomize the source port, just kind of rolling a die. Now, I'm definitely not going to choose a value that is below 1024, okay? So the source ports are what we call ephemeral, okay? And the source ports that is generated by the client is ephemeral. It's a randomized number. Let's talk about why we randomize. Okay, we're going to see this twice today. We randomize the numbers because we do not want people knowing how to talk back to us in spoof communication. Okay, so let's say I have a secure shell. Let's say you're working in a high secure environment. Okay, and I'm using secure shell. So that's good, right? Secure shell, it's secure enough if it's done right. I wouldn't want to have somebody be able to inject traffic back to me. Let's just say they knew how to reform encrypted traffic. I don't want them to even know my client's port. Okay, I'm going to obfuscate that. So this is a subtle obfuscation technique. Now, it's easily defeated if somebody can sniff the traffic. Okay. And that is part of a lot of attacks these days, is being able to sniff traffic in. And so it's not something it's truly hiding, but it is purposeful. And it is not there to just confound us as network professionals, okay? So now I want you to see this relationship. Look up top where my mouse is, okay? And I want you to see that these numbers bounce back and forth. Follow the 22 for a moment. Follow the 22, okay? So what you're doing when you're initiating the conversation is you're talking to the destination port. That's the port that server service, in this case port 22 for secure shell, it's listening on that. But that's where it's going to when it's coming back from that service. Let's say I'm secure shelled into a network device to manage it, doing my commands and stuff like that. It is going to then be coming from that source port. So I'm going to click, and I want you to follow the 22. I haven't clicked yet. So the first one was going to 22, but then it's going to come back from that server service. So this is expected for most of the application behavior. Okay, so it's maintaining that, but it's address, if you will. It's not technically an address, but it works like an address on that client. It's specifically targeting that specific session and that communication, okay? But there's that back and forth, okay? So we remember that. We remember that, okay? So, boy, there's a lot that we can see here, actually. I want to go back through our slides just because I have so much to talk to you about, and I want to make sure that, you know, we cover it in the way that I had conceived of covering it. We've now seen a little bit, right? We saw how that source and destination port worked. We saw a little bit talking about flags, okay? I do want to just mention, yeah, there are a lot of different TCP ports, okay? If you were in a certification exam like Network Plus or CCNA, you might have to memorize a few of these. In the real world, the most important things are to understand the protocols that are not secure. So, although we're, you know, this is maybe not the time and a place, there are a few of these ports that you really don't want to ever see in your network. Port 80, port 23. Those are some of the worst ones, okay? Telnet, we don't want to use it. Port 80, we don't want to use it. There's some other, you know, you could get on a soapbox. Anything unencrypted, riding above TCP is a problem. We're not talking about UDP today, because UDP doesn't have any of this elegance we're talking about besides port numbers. It's kind of uninteresting, and most interesting traffic is TCP these days. So if you looked at the traffic going on the internet, it's north of 90% of internet-based traffic is TCP-based. And most of the important stuff that happens in networking is going to be TCP-based that we care about. I'm not saying UDP isn't important, but, you know, we're choosing our battles today. We don't want to try to talk about UDP also, because there's plenty to talk about with TCP. Technically, TCP does more for us, and there's one reason that I really don't like UDP, and that is it doesn't have the windowing capability. And the windowing capability allows us to do bandwidth hog denial of service attacks a lot easier, okay? And so it's just easier to set up things on TCP because it is trying to be a very polite protocol. UDP is clumsy. It is lightweight, though. Okay, UDP, the thing that it goes for it is it doesn't have a lot of bulk. It doesn't go through rigmarole, and it is clean, okay? But today we're not going to talk about UDP anymore, hopefully. Okay. Let's see if I can hold myself accountable to that. All right. We're looking at the most important aspect of TCP. And, you know, we talk about theory sometimes, and I know how hard it is to see the importance of theory in the real world, okay? But this is the way that any conversation is formed in the world of TCP. It goes through this three-way handshake process, okay? It's got a SYN, it's got a SYN-ACK, and an ACK, okay? So this is first one of the early ways that we're going to teach it to you, okay? So if you haven't seen this before, great. So the SYN, the first segment, is a knock on the door for the port that you're trying to knock on the door of. So in this case, the packet capture in the screenshot is port 443. So I'm knocking on the door of the web service, specifically HTTPS. That's the web service that we use these days, okay? So I'm knocking on the door. Hey, are you a web server, and are you responding to web requests? And if I get a SYN-ACK back, that is important. That is proof that that device is running that service, is responsive to that service. Okay, so at this moment, if I were a hacker, I would be able to interpret that reception of a TCP SYN ACK. Okay, so this is what we call it. It's the SYN, then SYN ACK, then ACK. And that, you might, it's like, oh, this is weird. That's how people talk about it. It's not just me. I'm plenty weird, but I'm not trying to be weird today, okay? So I get a SYN ACK back. That's, at this point, the conversation is what we would deem embryonic, okay? Embryonic is the technical state for an unformed, like, primordial conversation, okay? And then the client says, yeah, I really do want to talk to you. Let's do this thing, okay? So let's see this in the wild, okay? So let's see this in the wild. I'm going to jump back to our cyber range. Assuming I can hit the right button. Let's try to hit the right button today. Okay. So here we have the three-way handshake. Okay. It is in the packet capture. And I didn't even have to look hard for it. Okay. So I found one TCP conversation. And what I did, by the way, sometimes I'll do stuff fast in Wireshark because this is not a Wireshark, event. But I just followed an individual segment to slice the conversation. Okay, so I just redid the thing that got us this. So I have lots of different segments. But now I'm just peering inside of one conversation that's going on. And so I can see the knock on the door. Okay, now let's crack open the flags here. So we can see how those flags are set. Okay, so I have a SYN, and then I have a SYN ACK. Okay, and so two flags are set. Two flags are set. And then a third part of the three-way handshake ACK, which is the, yep, let's do this thing. Okay. So this worked, okay? So now at this point, now I can send the data. So that's something that I do want to make sure that we're clear on. Because sometimes in a conversation at this level, we don't actually tell you what this enables. Now we can talk. Now we can have the session do its thing of sending actual data traffic. So it's a dependency. You cannot send TCP data until that three-way handshake is formed. But then once it is, the floodgates are open and things like that. Okay. So you know what I want to do? I want to see, some other cases here. So I'm going to open up a scanning tool. Okay. So what we're going to do is we're actually going to do a reconnaissance attack against one of the servers in this environment, okay? So we're going to generate some of our own traffic, and let's make sure that we're actually capturing it. So let's, start a new capture. Not going to save. And I'm going to clear off my filter. Okay. And I'm just gonna, we're gonna just do that. So I'm now just gonna look at traffic involved. Right now it's gonna be coming from one source, and I'm gonna generate some traffic to that. Okay, so I think those are gonna match up. I think you're gonna see, yep. 10 to 10, 80.10. So I'm actually gonna launch some traffic over there. This is, let's do an intense scan. And we can see some things that are happening right now, okay? So notice, now, this is not an Nmap session, okay? But what this does is it goes through this really complex script, okay? And the complex script is going to go through, like, tons of checks, and there's flags that tell us this. But what we're doing is we're like knocking on all the doors. we're jiggling all the handles from IP perspective. It's not full, but I mean, it's doing a lot. It even went so far as to establish an FTP conversation to this device. That's crazy, okay? So it discovered that this is an FTP server. Now let's go back to Wireshark, okay? And I'm going to make sure that I've applied that. And now let's look for some things that are kind of interesting. I'm going to stop this capture just because I don't want to see the scroll too much, okay? So let's go up. And actually, here's what I'm going to do. I want to... Here's one of the things that I do in Wireshark, by the way. I really like dragging and dropping filters. So, you know, none of us are, very, very few of us, let's just say very few of us are perfect with Wireshark. And we know it's a tool that can capture traffic. But what I want us to understand is we don't have to know all the syntax in order to work with Wireshark effectively. Because what you can do is you can open up the fields down below, you can drag them over, and I didn't type any of this stuff, and I refuse to type fresh in Wireshark. Okay, so what I have right now is some traffic that is still kind of mimicking what we've already seen, okay? Let's go back to Nmap for a moment. And I want us to see that this scanned, okay? This scanned the device. So if you've ever heard the term of a port scan, the term port scan is a scan of what services a device is listening in on, okay? And I can see that this device is running as an FTP server. It's also got some Microsoft goodies. Cool, 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 okay? Oh, RDP, 3389. That was chatted in earlier today also, okay? What if that three-way handshake never completes, okay? What if that three-way handshake never completes and it goes to an embryonic state? Let's see if we can find that. So what I'm going to do is this, okay? I am going to look for traffic, okay, that matches one of these flags, okay? I'm going to match one of these flags. I'm going to drag that over. And selected. And I dragged the wrong one, so let's see if I can. We're going to do reset equals true. Okay. Flags matter. Okay. Flags matter. Let's say we're under attack. And one of the attacks that does happen is reconnaissance attacks. Okay. So reconnaissance attacks are something that is a precursor to the actual thing that people are trying to do. They're trying to gather information. And if I were in my network and I saw resets, you know, what a reset is technically is that it's an abrupt end to the conversation. It's a super abrupt end to the conversation. But let's follow, okay? Let's follow one of these conversations. So I'm going to go in and we're just going to follow this, okay? This is an example of an unfinished conversation. So the way that a port scan works is we go through and we knock on a range of ports. So you could tell Nmap, hey, scan ports 1 through 1,000 or 1,023, 1,024, whatever you want to do, or all the way to 65,535. But notice what happened here. we never completed the handshake. Okay. So what happened here is I opened up, I sent a SYN. So that the port scan sent a SYN. I get a SYNAC back, and it's like, yeah, I'm open. And then we're just like, move on. Because we're not going to form this conversation. We're not going to try. Okay. We just moved on. It gave us the information we needed. You are listening on that port. So that basically is a prime target. Let's say you've got RDP open on some device and it's exposed to the internet. That means they could try to open up an RDP conversation. They would have to know the credentials, but I mean, credentials. They get out. What was the like admin password when that box wasn't even in production? Okay, so they just exposed that. Okay, so the reset. Okay, I'm going to go down here. That reset actually happened as a byproduct of the port scan. Okay, so we're not really gleaning information from it, but it is a telltale sign of a port scan that's happening inside of the network. And as you know, we don't want to be scanned. We are likely to be scanned, but it's not like something that we're going to be complacent about. I'd be like, yep, we're going to block that. Okay. So reset is something that happens. Okay. It's not a bad thing. It's not a bad thing in and of itself. Okay. But we should understand, hey, let's kill the conversation. Alternatively, okay, there is a different kind of gentler way of ending a conversation. And so this is a different flag. It's fin. So if you see fin, that is an indication that we are done with the conversation, and it's weird because it's a little less abrupt. You basically say, "Hey, let's be done with this," and then the other side acknowledges it, and then it says, "Yes, I'm ready to be done with it." So it's actually a 4-step process. Fin messages on their own are not crazy interesting. Okay, it's just a nice thing. But one of the things about knowledge, okay, is everything can be exploited. Okay, everything can be exploited. And so I'm going to go back to Nmap for a moment. And so theoretically, I could do a different scan. I'm not like amazing with Nmap syntax, by the way, but there is a fin scan that I could do. So that uppercase F would generate a fin scan. I don't want to spend too much time on it, but you could scan and reveal information about it by sending something kind of like unexpectedly, hey, I'm done talking to you. Like, let's say we got that and you were aware that the conversation takes place. That's normal, right? But what if somebody out of the blue says, I'm done with you? Let's say Brian tells me, he's in the chat right now. Brian says, I'm done with you. Okay, but I didn't know Brian existed, right? That would be an unusual thing for me. And I might actually communicate back to that individual, okay, who chatted in the port number for NTP. And, then I'd be revealing information about myself. So a lot of these things that we're talking about are leveraged by attacks. That's why it matters. Okay? That's why it matters. Firewalls, intrusion prevention systems, they are tuned to this. But we, as IT professionals, also need to understand how they work. And sometimes they're not going to catch it, right? There are zero-day threats. There are threats that are IPS and IDS devices, and firewalls are not catching yet. It's happened. It will continue to happen. Okay? So much to attack. So much to attack. Let's talk about this now, okay? And we've done some of these things already, okay? But I want to call attention to it. So what have we done so far? We've done a port scan, okay? What we're doing in a port scan is we're knocking on those doors for all the ports, and when we get a SYNAC back, boom, gotcha. Let's say I do that and you respond with the telnet port. You SYNAC on telnet. Ooh, let's focus our attention on that, okay? There's also something called a Christmas tree scan. Okay, so a Christmas tree scan is pretty unusual, okay? So the idea behind a Christmas tree scan, and you might hear this, is there's an unusual combination of flags that are set, okay? And people will tell you, oh, it looks like a Christmas tree is lighting up. I don't see the Christmas tree, okay? I don't see it, all right? But if you've flagged these three and they're not usually adjacent, they're not adjacent to each other in the bitwise analysis of it, that's doing a really just an unusual pattern. And sometimes you can reveal things like you shouldn't be sending, hey, urgent and push. Urgent is like urgent and push together is like I'm going to send you data, put this in the top of the queue, process it immediately, but I'm also saying goodbye. All right, that's weird. And so there's a flag for that. Okay, so we did some of those things. Now, let's talk about window size. Yeah, good. We're perfectly paced here. Let's talk about window size for a moment. You know, I've taught windowing at a lot. I've been a Cisco instructor for a while, like since the 90s. And, you know, what we'll teach you in a class generically is that TCP uses what we call sliding windows. And it allows you to send multiple segments, maybe many segments, without having to wait for response. That's great. You don't want to have a start-stop relationship. Older protocols like IPX, SPX had a start-stop relationship where it's like send one segment, await, get an acknowledgement. But that's actually not what really matters. Okay, like I really just, it's just knowledge that doesn't matter. Okay, what is the knowledge for windowing that matters? And you know, your mileage may vary, but you know, I'm just like, how many times in my career have I been impacted by window size? Okay, so not that many. Okay, to be honest. Okay. So let's talk about window size. There's a few things that I can tell you about it. Okay. So one, now this is part of a scan, and this is not an attack on window size. So let's actually, you know, let's do ports. I want to look at town. I'll look at FTP. Okay. Let's look at some traffic first. Just look for TCP traffic. And yeah, so there's a conversation here going on. We'll follow that. So in the relationship of two clients, there's something called window size, and there is a scaling factor. Now, I didn't do a good job of capturing that, so let me go deeper into this. Okay, let's go deeper. It's a good way to see it. So yeah, probably is good. Okay. So in the initial conversation that happens in the three-way handshake, one of the things that they don't tell you about often is that window size doesn't work like we teach it to you usually, okay? So we're going to go into options, and we're going to see this thing called window scale, okay? So how window scale works is at the formation of the conversation, we set this thing called the window scale factor, okay? So it's baked. This part doesn't adjust. The window size does, but the window scale does not. Now, here's one reason why you might not have heard about this, okay? I don't want to install the latest and greatest. Because it's kind of new. It came about in Windows Vista, okay? Now, that may or may not be new to you. But this didn't exist in like Windows 95, 98, 2000 XP, okay? At least it wasn't part of the launch. But Windows Vista and beyond started to support this thing called window scale. And it's just, it makes sense. We need to be able to send more than 64K of data. And so there's some little math that happens. So there's a numeric value baked into the number here. And the number can go up to like 13. And in this case, it's 7. And so the total amount that we can send without waiting for an acknowledgement happens to be 128 times window size. Now, if you're trying to figure out where the heck did they get 128, I see it right here. It says it because this is actually Wireshark telling us the interpretation of the value of 7. So here's the deal. This is based on a power 2. So if you see 8, it would be 256. If you saw 12, it would be 4096. Okay, so that is an indication of how much. So you really can send a whole lot more than just 64K. That's a little confusing, right? Because a lot of times we just don't talk about that. There's something that is an issue with windowing, though. So what if you were able to send traffic, inject traffic into a traffic stream? Let's talk now about TCP session hijacking, okay? So before I get there, most of the nuance of this usually isn't covered in a normal discussion. TCP session hijacking is something that is possible, okay? And it allows you to do some really scary stuff, okay? This is government level hacking typically, okay? So we're doing it with not like small budget type stuff, not like script kiddie type stuff. Although, you know, there probably are some script kiddie. But these quantum insert, quantum sky, this is Edward Snowden's, you know, exposed these two. There's a bunch other quantum. And what it revealed is TCP session hijacking is still a thing. Now, there's an old hacker who's still around, who's still a big deal, called Kevin Mitnick. And he did a lot of the early day hacking. And he demonstrated this idea of taking over a session and basically inserting segments, okay? Inserting segments. And so it's a tricky thing to do. So if I can insert a segment, I could redirect you to a different web page. So one of the big threats that happened, you know, like 9 years ago was we still were using port 80. And if you can hijack a session that ultimately is conveying HTTP, you can perform a redirect to your own server. You can be like, you know what? I'm going to redirect you. So a lot of web servers, okay, most web servers are listening on port 80, at least a lot of them, okay? And what they'll do is they'll say, oh, you came to us on HTTP. We're not going to do that. We're going to bounce you to HTTPS. That's a very normal thing. However, okay, that does open up the possibility that somebody other than you redirects. And HTTP is not encrypted. but you do have to hijack the session. You could also send TCP resets. You could also change the window to 0, which says, I am not ready. Specifically, if you ever see a window size of 0, that says, my buffer's full, don't send me any more. That's normal behavior. That's how it's designed. But what if you were trying to thwart communication going to a particular place? You could send 0 window and it would shut down the ability to send. You'd be like, all right, I'm going to back off. And you might think, well, how are these used? We've seen things like TCP resets in the Great Firewall of China, okay? So these things are used, okay? These things are used. Sometimes just kind of for slightly, kind of benign reasons, but we should assume the worst, okay? Now, why is this a talking point here? Okay, so we saw a bunch of attacks. If we're going to talk about something that, you probably have never really seen a deeper discussion of, this is one of the things that's really cool, okay? So what I want to do is I want to go over sequence number. Now, here's the deal. We're not going to follow sequence number progression. That's kind of okay. The reality is it's a numeric value that follows how many bytes we've successfully sent, okay? And it's a progress indicator. So, if you're reading a book, you've got a bookmark, and it tells you you're on page 2 or page 50. It's just, this is the bookmark for the conversation, okay? And so the sequence number is not how we teach it to you. Sequence number is randomized and obfuscated, okay? So, if you ever go and you're in Wireshark and you're like, why is the sequence number, it's represented as 0 here, but it's showing a different number, okay? So here's what happens. In the formation, the three-way handshake, in that three-way handshake, there is a sequence number that is chosen by my side and by the far side. Okay, so we both roll the dice. Okay, and the reason why we do this is because it allows us to defeat a lot of attacks. Because if you can guess the sequence number, you can start to inject TCP segments. Now, you might think, well, I could still sniff the traffic. Right? So in order to sniff traffic, let's say it's on the internet, you have to be on the ISP or maybe have hacked the ISP and done a TCP dump, okay, and set up a script to take packet captures real time and process them. But what we have to understand, this is actually very, very important, deeply important. So people without the ability to sniff my traffic that's over TCP cannot guess this. It's just too big a number, okay? And so the sequence number defeats a lot of attacks, blind attacks. And you might think, how big a deal is this, okay? Well, let me tell you. Let's just say you've got a border gateway protocol session. This attack really spoke to me. You've got a BGP session. Okay, border gateway protocol, the routing protocol of the internet. And if I wanted to inject traffic myself, and it's not encrypted traffic, I am going to be able to inject conversations and change routing on the internet. I could reroute traffic to my own side. I could reroute traffic to a different part. And this has not been observable in the wild, but we have seen other BGP attacks where people have redirected traffic. Let's say United States to Japan gets redirected from United States to North Korea to Japan. We've seen BGP attacks like that for different reasons, okay? But we do care about this. So basically, it's a numeric value that is chosen by the endpoints. It's not predictable, and it helps us thwart a lot of attacks. And so we've now seen a whole heck of a lot of different attacks and different fields. Pretty much covered what I wanted to with you guys. So I want to take a moment to go back. Okay, we're going to go back here. We have seen now a lot more depth than you might have seen in a previous discussion on TCP. Okay, so we saw that relationship of source and destination ports. I choose one at random, I go to. How would you apply this in the real world? Well, one of the most typical places where you do that is you build filters. But now I want you to think, is it a destination port? Let's say I'm trying to prevent traffic coming into my network on port 23. So what I would do is I'd choose the destination port of 23, not the source port, okay? I want to make sure that I'm controlling that initiating conversation so the SYN doesn't get there. The SYN is trying to go to the destination port that is predictable, okay? So in Cisco, for instance, we care deeply about that when it comes to the configuration of an access control list. We learned about sequence number. Not that this is a progress indicator, but we learned about the randomization of it, which obfuscates and makes it harder to inject TCP sessions, okay? We learned a lot about flags. Actually, you're not, like, if you're going into a deep security class, you'd have to get really deep to need all the stuff we talked about. Window size. You could attack this vector. You could say TCP window size of 0. And we learned that it's also affected by some of the options that are downstream of it.